Hello, 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 everybody. Welcome to Generation AI, live version of Generation AI, where we demystify artificial intelligence to the world of higher education and beyond. I'm your host, Ardis Kadiu, and joined with me today, I have my insightful co-host, JC Bonilla, and a special guest, CTO of Element 451, friend Petar Djordjevic, the wizard of AI. Is that a good title?
That's not good.
It's
Stick with
cringe,
you.
right?
Yes, it is. It is.
What's up with Peter getting all the compliments and I just get like, hey, my co-host, huh? What's going on here? I
I
take
think
vacation and Peter
I think
shows
it's like
up like
marriage,
three
right? You've been
times, taking
yeah.
over. What is going on here, everybody? Basically this is an intervention. Peter, you're not taking my job.
Let's see.
Peter,
Give me a
artists
few
and
more.
I are a thing.
Well, welcome everybody. So today, we wanted in today's episode, we wanted to do a live episode, and we're publishing this on YouTube Live and LinkedIn as well on my LinkedIn. But we'll also publish it in other channels as well. And we are really excited to kind of dive a little bit deeper into the OpenAI latest model, the O1 model. It just came out yesterday, and we wanted to kind of introduce it. It's also known as Strawberry. So this model really marks a very significant leap forward in terms of the world of AI because of its reasoning capabilities and kind of where
Mhm.
we've been and how it's trained, and the way that it answers questions and it solves problems. So I brought in Petar and JC here today, to kind of dive a little bit deeper into what's happening and provide some commentary, going a little bit deeper into some of the training behind it, kind of what it means, how is it different, and kind of demystify it a little bit as well. Should we start with you, Petar? What is the O1 model?
Sure. So O1 is a new, probably a future flagship for OpenAI. It will go side by side with the current GPT-4o. So it's not meant to be a replacement. It's meant to be kind of like a new model that we use side by side. Its main purpose, or what they're trying to solve, is how can they make AI better at tasks it hasn't seen before, and more complex tasks that can be either following a diverse set of instructions or just complicated domains. And those complicated domains can be, physics, quantum physics, going deeper like DNA, that type of stuff. So why they call it Strawberry, codename Strawberry? That's an interesting one. There's a test that has been used on various language or large language models. Is can you count the number of letters R in a word strawberry? And curiously, all of them fail. They will mostly say two or four. So this model can do it correctly. It'll do three. Why it does that? It's kind of like how a lot of large language models are implemented. They don't see letters. They see kind of like something like a subword, not even a word, like kind of like a subword. So it's really hard for them to do that, especially on the first get go. But if you tell them, hey, if you think about it, calculate and then give me an answer, it will do it correctly. So that's actually what this model does. Instead of like outputting you the answer immediately, it has been trained to think carefully about the problem, and that changes now. So that means this model is slower, and it will be slower compared to what we have. So that's why it doesn't replace GPT-4o. But because it thinks carefully and takes its time, it's able to produce you that correct answer for more complicated problems. So strawberry is a simple problem, but you can ask it like really tough economics questions or even like quantum physics, and it's able to write you formulas and calculate. So it's a big milestone, I think, in terms of current development. My opinion is we have been seeing something like this already. It's not new. I mean, their results on benchmarks are amazing. If you go in an OpenAI website and take a look at what kind of benchmarks they did, it's crazy. It's like the jump in capabilities is huge, but mostly around really complex areas. In terms of writing, there's like if you need just for like marketing, it's
Mhm.
not going to improve that much. But math, computer science, just programming competitions, Olympiad, the increase is like 50% or even 100%. So that's what is major here.
JC, it's also noticeable that now OpenAI has moved away from the naming convention of GPT and they're actually introducing the O1 model. So when you see it, it's just the O1 model. There's no GPT before it.
Right.
So it's interesting how they're moving towards the naming convention as well. Now GPT can be technically called GPT-5, or some folks are calling it GPT-5, but it doesn't really matter at the end of the day.
Doesn't matter.
Productizing and kind of owning the brand is a really important move. How many of you guys are excited about Apple iPhone 16? It's hard to count and things of that sort. So I'm glad that there is a shift there. And GPT, in terms of brand, doesn't do it for me. O1, maybe. The thing that I find very interesting, and this is building off of the commentary we've been carrying on the podcast, it's that with this new introduction of Strawberry, complete tasks and the idea of performance need to be separated. I don't think many of us are impressed with faster, cheaper, better. It's like kind of expected, right? And this is basically what we've seen for people like me in the semiconductors industry. Like all of a sudden, like chips just become faster and faster, and all of a sudden, like who cares, right? It just has to be better, and we expect that. So the expectation of Strawberry deploying at faster, cheaper, and better, non-trivial. But the aspect of how reasoning is starting to basically be played out, specifically as it relates to context. I was just having drinks with a friend last night, and oh my gosh, atrocities of how LLMs, chat GPTs of the world work in DevOps. Sure, they can write code, but they don't understand how to plug in with all these legacy type of things. So all the time what you end up with is not solving the problems that we want them to solve. So reasoning, specifically these type of reasonings that we've been talking about, human AI collaboration, the idea of common sense reasoning, the aperture towards that, this is what Strawberry is deploying today. An ability to come and plug in with the things that we need that really allow the applications that we're going for be available. So I'm excited about that. And we'll see when we get to touch it, because being
It's available.
slow. Yeah, but to your point is like it was slow, or you think it's not going to.
They might improve the compute to be faster. As chips get.
That was my point.
Yeah.
Let me ask you the question. Are you guys shifting to Strawberry like tomorrow?
No.
That's my point. That's my point. It's still too new. It's kind of like it needs to do its reps, right? It needs to break a bit more before you jump right onto it.
Yeah, they're trying to get feedback now. So this first model is actually released even without support for a system message, which is kind of traditionally used for currently available models to kind of like fine tune the experience that you want from a model. It doesn't have tool calling, so you can't really integrate it easily into your systems to call like functions inside of your systems to perform actions, which other models currently can. You can still tell it, hey, produce me certain format, and I can understand it, but they will go there as time goes. I think like 1-2 months, they'll probably implement all these features that kind of like you expect to use this in production grade. Right now, they probably want to get feedback because it's really interesting. One thing that I saw, and it's not. That's why I say I don't think it's new. For people who used Claude, and especially used Claude to actually use it in your application, for example, Claude did the reasoning as well when it outputs something. So you don't see it when you use the Claude interface, but if you use their API, you will see that Claude, when you call it, it will first give you like, hey, this is my kind of like reasoning block, like this is what I'm thinking,
Yeah.
and then it will give you the answer. OpenAI GPT didn't do that.
But I think you're hitting on philosophical ideas of how transparency is carried out on these models. And Claude, as far as I understand the development team, one of the reasons why it's separated from OpenAI is because they go for that. Circa this summer, when they actually published their research on features and reasoning, it's incredible, right? So they really open it. So no surprise that they're telling you, I am LLM Claude, this is how I got there.
So I'd like to share a quick video to see like how this actually works.
The first example I have is very simple. This just counting the letter R's in a word strawberry. So let's start with the traditional, like existing model GPT-4o. So as you can see, the model fails on this. There are 3 R's, but the model says there are only 2 R's. So why does this advanced model like GPT-4o makes such a simple mistake? That's because models like this are built to process the text, not with the characters or words. It's somewhere between, sometimes called a subword. So if we ask the question to a model, a question that involves understanding the notion of characters and words, the model can really just make mistakes because it's not really built for that. So now let's go on to our new model and type in the same problem. This is an O1 preview, which is a reasoning model. So unlike the GPT-4o, it starts thinking about this problem before outputting the answer. And now it outputs the answer. There are 3 R's in the word strawberry. So that's the correct answer. And this example shows that even for seemingly unrelated counting problem, having a reasoning built in can help avoiding the mistakes, because it can maybe look at its own output and review it and just be more careful and so on.
Ardis, can you maybe show the example which is that physics puzzle of the strawberry in a cup? I think that's a little bit better to illustrate the capabilities.
OpenAI's long-awaited strawberry Q-star model.
Sorry, guys. All right, so let's go back to. So we're gonna. I'm gonna share. So if you go to the OpenAI website, there's a whole bunch of videos in there. Petar, which one is it in here?
Go right.
The logic puzzle.
Yeah, that one. Left one.
The reasoning.
Left. One time left.
This one.
Yeah, that would do that one. Yeah.
Okay.
I really like this puzzle because it's been a puzzle from a computer game I've been playing as a kid. The riddle reads as: a princess is as old as the prince will be when the princess is twice as old as the prince was when the princess's age was half the sum of their present age. Even if it even reads hard, it's kind of like it takes a while for a human to understand and translate this problem into how to actually solve it. The question is, what is the age of the prince and the princess? And let's ask our reasoning model how it will do with that. And again, we can observe a little bit its thinking process through like decoding the problem, understanding what are the equations that the ages of prince and princess need to fulfill, and let's see for how long the model will need to think about it. Just similarly as humans sometimes think longer and shorter on a problem, our models do the same thing. And after a while, I hope the model will give us a correct answer here. The model is still thinking about it. It's not the easiest problem, but we got the answer just right now. The model also walks us through the solution in this case. What are the variables? What are the conditions? How to translate this problem into English?
This is very
how
impressive.
To solve those equations where they are just real time.
And what's really interesting is, remember before,
Together we even got a message about verification, and we got the answer where the prince's age is 6 times k for any natural number k, and the princess's age is 8 times k, that natural age, which also is the correct solution for the problem in that game.
So remember before, every time you wanted to solve something like this with current models, you always need to tell it, hey, you are an expert this, you're an expert that, be careful. You kind of need to put it in a setting to perform well. And you see in this example, you didn't need to do that, right? You just gave it the problem and it started doing and became an expert on analyzing and became a really good mathematician. So this is what this gives them ability from user interface and user experience perspective. It's much easier. You don't need to learn tricks how to use AI models, right? You don't need to be the expert prompt engineer. Just give it your problem and it'll figure it out, what it needs to be, what needs to become, how to think.
Right.
And do it. So it's really exciting, right? If you think in deploying AI now across the board, right? Because one of the problems is prompt engineering. Still, it was prompt engineering. You need to learn tricks. You need to remember, hey, these are the gotchas, how you get what you want. And most people didn't knew that, and they would try to use AI. They will not get what they want. They're like, hey, this is not good. I don't want to use this. It's just snake oil or whatever, and they will not see the benefits until they kind of use it properly. This removes that friction, right? So this is amazing. Amazing.
Go ahead, Ardis.
No, I wanted to do a follow-up on that, Petar. And what are the problems that we're seeing today with the LLMs or the large language models that are available? The frontier models that we're talking about. We're talking about GPT 4.0. We're talking about Claude Sonnet 3.5. Like, what are the problems that we see there? Like, what's the limitations?
There's many, but one thing is, again, they are as good as how you use them as well. Like they're not like on their own, they are great, but if you want them used in a production setting, you need to learn how they behave and to kind of like fine tune them and see what instructions actually work. That
Mhm.
takes a lot of like trial and error. um, Having that removed, I mean, theoretically, if this becomes faster and you can run this, I'm not sure if that's theoretically possible, but if this becomes faster, you will not need to do that. It will be much easier to plug it into your applications, which means that any company would much easier be able to integrate AI into their products and then kind of solve their problems differently. Right now, that's a barrier. Like a lot of customer companies are trying to use AI to solve problems, but they're still struggling. You might see a lot of your products that do have AI, but there's a vast majority that are still figuring out how to use it and how to use it correctly.
Yeah.
Hallucinations is another problem, right? Giving you information that's not correct. That's still not solved even with this approach. I've seen it's still early, but I've seen people report it hallucinates more. Some people say it hallucinates less because it thinks more. So it's still left to be seen. But there's still problems and limitations of current models. They are not a silver bullet, which makes sense. No technology is perfect. There's always a drawback. If it was perfect, like, the life would be easier.
Yeah, we're talking specifically around like the limitations on what was different before and what changed
Sure.
yesterday.
Sure. So what you saw in the demo, you saw that part where it was doing that internal thinking. They didn't want to show you how it thinks, and that's something that OpenAI decided to do
Sure.
because they're like, hey, this is important. Like this thinking process needs to be kind of like included in the result because the model will behave better if we like give it. They call it like also these tokens, and this actually costs you if you use this in production. But this actually costs you money as well, even if you don't see it. So the thinking process also costs you. But they wanted to keep it probably kind of like their own secret because they can fine tune it, and that's kind of like what's their kind of differentiator. But secondly, it's hard to do moderation on that, right? Because when you do moderation, you need to be really strict, and then you also limit capabilities. And we saw that in previous versions of GPT, whenever they added more and more moderation to make it stricter, to not give certain instructions, or that it eventually caused the model to actually be dumber. So they decided, hey, because we cannot moderate, we will hide it. So there's a whole thinking part, which before you would be able to see. Before, if they decided, you would be able to see that as text, which is now collapsed. You don't see it; it's hidden. And all that text. So what will happen will be that chain of thought reasoning that we talked on the previous episodes, where the model tries to break down the problem step by step. So you saw that twice. You saw it. You didn't see it in the thinking, but you saw it in the final output, because they trained it also to include parts of that reasoning in the output, so they kind of like assure you that the model is doing things step by step. So that's why it's so slow. It takes a long time because it will try to decompose a problem into really fine-grained steps and try to solve it. But what's really interesting, it can backtrack. So it's not just like, hey, following a happy path and then ends up wherever it went. It can try one way.
Right.
It's wrong, it can go back and then retry again. So it tries multiple solutions to get to the final answer, and that's different. That's different from before. Before, you would see an LLM probably follow one path until success or failure, and then people will see, hey, it's really confident that it's wrong.
Right.
The point,
That's the problem. Remember, there was so many prompting techniques. It was obviously the chain of thought has been a really good prompting technique. That's essentially basically the way that this LLMs works is chain of thought is like the more steps that you have, the better it is at getting to a better answer. The more tokens, the better chance it has to get that right. So that's why chain of thought techniques really worked when we did prompting. But then people were coming up with some crazy like tree of thought and
Yep.
a few others that essentially what they were doing is following certain paths and then self-evaluating back on the model saying, okay, is this true or not? Well, now those types of techniques, the reasoning part is baked into the model itself. It's like the model can actually understand and provide all of those reasoning and do all those steps on their own in the background and then back propagate, like you said. So that's very, very different.
and the important part that I like everyone to follow here is prompting is a new language for
Right.
users that you need to learn to basically be sophisticated and impactful on LLMs, right? Whether it's ChatGPT or Claude, you have to prompt. And I'm gonna say this ain't human. Thinking and speaking prompt, it's not human. It's not how we socialize. And if anything, that's why Ardis is a much better prompter than me, right? Because he does this sequencing type of thing, and it goes back to what Peter is talking about, understand the model and so on and so forth. So the leap forward that we're seeing with this drop of strawberry is that the barrier from prompting, good prompting, and a good answer gets removed, right? Because now there's a baked in, as Ardis just mentioned, a baked in component in reasoning that allows me more casually, this is what I need in fill in the blanks, right? Without the need to be sequential, structure, and following the prompt and formula. That's really exciting. And we're still not there yet, right? So the fact that my last point is that there's always two versions of an LLM or an AI type of thing. The one in the back end, the Petars of the world, that you will do the DevOps, and that's a black box. And everybody, that is very powerful. And this is how probably most of the compute use cases are being deployed today. Really interesting, but we don't even see it, right? It's basically back end talking to back end and models doing its stuff, and then tons of engineering covering and filling in the blanks. But there's the front end experience where the user will come in and interact. And I think that that is a really important and step forward that is worth calling today. That as little prompting as we know it today is needed, the more usability and adoption is going to come, because that's really what's happening. We don't prompt in day-to-day action, human action.
And it's not just, hey, you don't need to prompt a lot, but look at the performance. Or maybe do you have maybe the benchmarks that you can maybe post on the screen?
Yeah, let's see if we can.
Because I just want to illustrate like what are the improvements compared to GPT-4o, which was kind of like state of the art, like compared like with Gemini and Claude. There were three state of the art models out there. And I'll take a look at the improvements on like STEM benchmarks from like Olympics for computer science to certain mathematical benchmarks that are actually used. So take a look at this. So on the left, GPT-4o, that's the current model that's currently deployed, probably that people will use. That's like state of the art. And take a look at the improvements on the O1 preview that we got now, and there's O1 that probably will be deployed afterwards. I mean, that's crazy. Look.
Yeah, I mean, this is incredible. Look at the competition, the code
forces
coding, right? It's incredible. Look at that. 11 for GPT-4o, which is the frontier model, and then O1 preview, and then the O1 model. So what's the difference between the O1 preview, Petar, and O1?
I'm not sure still. I think the O1 would probably be the model when they release. So preview is now what they gave us. O1 probably would be with all the features, system prompt, all the tool calling, be able to connect to different systems. That's what I expect. But maybe I could be wrong.
JC, what I mean as somebody who's teaching like analytics and statistics and kind of in colleges in your classes, you know, how do you think about this?
I'm going to give you two answers, right? The first answer is fascinating and the opportunity is giant. Theoretically speaking, when I teach modeling, when I teach statistics, summary stats, predictive stats, right, there's a process and it's going to follow like one of these exams that people take, right? So theoretically, learning and execution, the leap for computational tools and LLMs, it's fascinating and it's very promising. I trust, I guess now, a algorithm to solve this problem better than the human. And actually you saw it in some of these stats that the algo, the technology does better, the models do better than the human expert. Now, practice. This is the part that is the second aspect. When it comes to practice, the difference between theory, what I teach in class, and when I run teams, and when you guys were part of my teams, you know what? Where the half of the time of an analyst is spent today, it's not doing analytics. It's QAing data. It's basically trusting the data, doing these things that are not analytics, and it's basically the reps are really, really important to be done. And that's the part that I don't know. I need a debate. Political vibes now. I need a debate of where is this going to uplift, to remove how we technology folks, analysts spend the time today on the workplace. Half of the time, if not more, it's basically on can I trust the data, QAing the data, preparing the data before you do the modeling, the analysis.
Right.
And that is really
Right.
hard because you need the context. You need to understand how these campaigns were executed. What are the 55 issues on the taxonomy, and how do you queue it up? And then think about how you guys have put rubber bands on the product, so that not rubber bands, incredible technology solutions, so that your different hundreds of partners can utilize taxonomies and their own identity and their deployment. Stuff like that and you control your technology. When you don't control it and it just basically data pulls from all over the world, it's super, super tough. So that
Yeah.
part, I don't know if it's going to be
Well, the reasoning there hopefully should help us out with that.
So
in
there's another
that.
example. There's another
Sure.
example that they posted. There's a geneticist, and she does the kind of like the n of one problems, when like nobody has seen before, or people that kind of like have a problem that nobody can help them,
Mm.
and like the toughest one. And kind of like her problem is, if you think about it, following rabbit holes, right? Which she tries every day to try to solve it, but to do that, she needs to follow different signs and kind of like go in one direction, then go track back, and loses a lot of time. And they actually did a video with her.
Yeah, let's take a look at that better, because this is let me share my screen again.
And basically what she said is, yeah, if this helps me,
It's
like,
impossible to be an expert in every single gene. There's 20,000 genes. Like, you can't keep everything straight, but AI can. My name is Catherine Brownstein. I'm a geneticist here at Boston Children's Hospital. I'm also scientific director of the Mann Center for Orphan Disease Research. I deal with the N of 1 cases where no one has seen that presentation before. Patients don't know what's going on. They're really medical refugees in some way. It's like wing walking. Like, you're seeing things, and you're seeing genetic things, you're seeing phenotypic things, and you're trying to connect them, and none of it's been seen before, but like, you think you are the only one in the world, but really sometimes there's a whole community that just haven't come together yet. When before I would look up an article and then look up another article and then look up another article. Chat with reasoning is so much easier to use. It's just a quick prompt to summarize it for me and then summarize this part for me. I mean, it's just way, way faster.
So that's the one thing that's really interesting, is essentially it's kind of replacing, I won't say replacing, but it's getting a lot better at following, maybe similar to like the scientific method a little bit. It's like, trying things out and then reasoning like why it worked, why it didn't work, and then move backwards and then try something else, something new.
Mhm.
But because it can do a lot of that, because of the massive amounts of data that it has ingested, the reasoning part, you can introduce it to a new data set, or you can introduce it to a new corpus, and it's able to actually incorporate that information as part of it. I think the part that's going to be really interesting here is going to be the fine tuning, or the RAG operations, or the the ways that this gets overlaid on specific data sets, or what they call, I think Ethan Malik, he posted a couple of things last night that he was playing around with this, and one of the things he said, AGI is here, is just very ragged, right? So ragged, this idea of it's gotten to, it's really, really good at one specific use case, right? It almost AGI, very narrow AGI, almost reasoning, but you have to apply to different areas. And if you do that, then you essentially get to superhuman capability, or even PhD level capabilities, but you have to apply to a specific domain. It's not generalized just yet, right?
Yeah.
So maybe that's here now, as we're seeing with some of these things. I wanted to very quickly, JC, you mentioned something around marketing. So I went ahead and I did a really, really quick prompt here.
This is
quick
O1?
examples. This is the O1, yeah.
Okay.
So yeah, this is the O1 preview. And I did something very quickly here. So I said, assume you're a marketing CMO at a university. Well, of course, redundant. It's a terrible prompting, but your digital team said that leads are down for the month of January, but the traffic is up. What effect does that have on the enrollment for next year? It's like, you know what I mean? This is a very interesting question. And as you take a look at this, it kind of thought for about 11 seconds. So traditionally, this is very, very quick, but let's take a look at this. It says, understanding the context. The assistant is asked to assume the role of a marketing CMO at a university with digital leads down traffic and to predict effects on the next enrollment. So it kind of understands the context. It translates that. So you no longer have to write things in, you're a marketing CMO, you're this, here's your context, blah, blah, blah. Like it's actually extrapolating that from just the content that you're giving it. It's pulling pieces of information, which is really interesting. Assessing enrollment impact. So he broke that down. The task is to examine the effect on next year's enrollment, identify reasons for increased website traffic, but fewer leads, and explore potential solutions. I mean, you give that one sentence to somebody, and then if they're not an expert, they have no idea what to do. It's like, how do you break this thing down into multiple steps so you can kind of figure out? So here's the second part. The third one, pinpoint causes. I'm analyzing potential reasons for decline in new student enrollments, such as website hiccups, off-target traffic, and increased competition. Okay, so it's not giving us because OpenAI decided, like Petar said, to hide all the steps of the reasoning. What they're doing here is just a summary of that process.
Yep.
So there's a lot more steps happening behind the scenes that we don't see.
If I ask you, gentlemen, my web leads, I think that was a prompt, right, are down. What do you think immediately? Try not to look at this. Ardis and Petar. I'm a CMO for university. My web leads are down. What's the problem? Where does your head go next?
You're not spending enough, or your messaging is terrible.
I'm surprised you're actually giving an answer. You need more.
Okay, so I have to ask you questions, right? Okay.
It's like, wait, what kind of school? What kind of school are you? Is this fall? Is this spring? There's like 7 questions for a human to give a thoughtful answer. That's the expert use case that I did though.
Right? I gave it more context, so I did. I should have left it at that. But yeah, I did give it more context. So you're right.
Yeah. So the part that the expertise, and this is where I want these models to go, is like, don't force the answer. And this is where not even hallucinations is a problem, right? It's just that basically you get all these cookie cutter things, right? And this is halfway there between depth and cookie cutter approach. It just
you haven't
literally
the answer yet. So we have a skeptic. We do have a skeptic.
Sure. It's just because I know that, and because we're experts, you cannot answer this question with the information provided. There's nuance that is needed for me to basically give you a whole reasoning. I appreciate the transparency in the logic model, but there's more. You guys understand what I'm trying to say?
Yeah. True. But LLMs are kind of like thought to be too helpful. So sometimes it might not continue to ask you like follow-up questions.
I love the logic model. I think I'm impressed with that. I would love if it says, can you tell me more? 1 or 2, 3 questions to basically generate these things, and I would be like blown away. But I just don't know if we're there. And this is basically because I'm big on these human AI learning collaborative systems. And that's basically what I think this is going to go next. All right, continue. I spoil your demo.
No. This is great. And I want to come back to that topic, by the way. I want to really come back to the topic. So So essentially, what it's doing here is just going through the spotting a trend or evaluating the sources and paths, right? It's like, is it saying how examining traffic sources or reviewing conversion paths can reveal bottlenecks or drop off points? So it's doing all that stuff in the background. But let's take a look at the actual output that it gave us. So let's not look at the reasoning part. So the output is increase in traffic coupled with a decrease in leads for the month of January is a significant concern that can negatively impact next year's enrollment number. How does this scenario affect enrollment and what it might indicate? Impact on reduced prospect pool. So leads to represent, so it made the connection around, the leads and enrollment and all that stuff, showing interest. A decline in leads means fewer prospective students enrollment funnel, which can result in application enrollment down the funnel. Lower conversion rates, uptake in traffic with fewer leads suggests that your website or landing pages are not effectively converting. I mean, of course, that's pretty generic, but this inefficiency can hinder the overall effectiveness. And then forecasting challenges. With fewer leads, it becomes more difficult to project future enrollment. So, okay, so this is the possible reasons for the trend, right? This is what I was asking it specifically. Quality of traffic. Additional traffic may not be from target demographics. Increased visitor from non-prospective students, like bots, international audiences not eligible to enroll, or irrelevant geographical locations. Website experience issues, like we know that that's an issue sometimes when that happens. There might be glitches with your forms or submitting. Ineffective calls to action, compelling, and then content misalignment. Website content may not be resonating. And then marketing channel mismatch. I think this last one is actually a pretty good one because I think this is where we go quite a bit. Sometimes when we have high traffic and low conversions, it's like increased traffic at channels that historically do not convert well, like certain social platforms could be diluting overall lead generation efforts. So sometimes when you look at, like, this is really probably the best, option that I would have gone to if I was just given that answer, because it's like, okay, you're getting people to your website, but let's take a look at your sources of where those people are coming from and that traffic and why, is. And then, of course, gives the recommendations in here. And let's take a look at the conclusion. The current discrepancy between increased traffic and decreased leads suggests disconnect that could lead to lower enrollment. By identifying and resolving this issue, of course, it just does a little bit of a summary because I tried to connect it with the enrollment part. But anyways, I think, some good recommendations here without giving a lot of context and very little context. If we go ahead and do this let's do this in chat. Let's do this in, I'm going to go to GPT-4o and I'm actually going to do the same thing. Okay.
Yeah,
So
it doesn't have depth and logic,
okay,
model,
so
and reasoning.
you see the difference here?
Yeah,
I mean,
of course.
huge difference, right?
Yeah.
It just
And
basically made a direct connection to say, okay, fewer leads means, less people in your funnel. That's it.
Right, and you see, kind of like, as the problem is open-ended, as JC said, like it doesn't have a lot of context, and
Correct.
like to his point, like it would be better even if it were to ask you some questions to gather that, so it can probably analyze the situation.
Agreed.
I think what it's optimized for, it's optimized for that, like, hey, single message out, and then try to help you immediately as possible. That's why it doesn't ask you the follow-ups. But it did try to go different directions, right, and thought about it carefully. So it's a little bit different, correct? So if you're talking to a human, you would like human first to ask you sub questions to gather the information. But I guess it's more optimized here to give you, like, with the least amount of latency, right? You don't want to have a really long chat. Potentially, most people, they want to get an answer immediately. But this is a really open-ended problem, right? You can go very, very different ways. So then it is, can you ask the questions or clarify or go deeper and then like highlight pieces that make sense for you.
So JC, do you have another question or do you have something else that we can take a look and try?
Oh, on the fly, no, but I can think of something if you want to do. You mean like another prompt that we can differentiate?
Yeah.
But let's do something that's.
I would love if we have data available. I would love to see, like, what's wrong with this data. Like, really, the ability to look at patterns and things of that sort. I don't know how much depth and context. this is the use case I want to replicate. Ardis, Petar, you guys are managers. How many times 20 hours worth of work have been done in some type of thing, and it takes the manager a nanosecond to say that's wrong, right? Why? Because that cannot happen. That's wrong. And you send the analysts, the engineers back, and like they come back like, yeah, I just didn't see this, right? Or the data was wrong, or the code, whatever, right? So where is this, as an expert, really understanding the reason in the context, right? And that's where I'm trying to see, can you pick up the problem just the way I would with a nanosecond, and a junior person cannot. I just don't have that.
We don't have that right now, so we can do it live. Okay. So what's the next best thing? Petar, do you have anything?
No. Thank you.
Freaking Ardis, like putting us on the spot, man.
I know. I apologize, guys. It's like one of the episodes that's going to come up. So we did 2 episodes on reasoning. JC and I did, and so next Tuesday and the Tuesday after, or depending on how we put those out. But we did a couple of episodes on reasoning, and we talk about like how you think about reasoning, like how reasoning systems work, and so on and so forth. So if you're really interested in some of that and understanding a little bit more, and we even did a little bit of work around the synthetic data that needs to be generated around this. That's coming up as well over the next couple of weeks. But let's go back to.
By the way, Ardis, before we go back, I just want to say that maybe what we could do is come back, and each of us bring a problem that we think is going to be interesting, and maybe we'll do another live session. Petar, you recruited. You've actually done really well. So I welcome you to our family. You're no longer cheating on me, Ardis.
Wait, are you saying that he can be a continued guest on the podcast now?
What I'm saying is that he's hired.
I accept.
He's hired. You passed the test, my
you didn't even negotiate.
By the way, I so enjoy seeing your hand here and there and seeing the wedding band. Congratulations, Petar, the married man. So anyway, I digressed. Ardis.
So as we wrap this up, guys, one of the things that's really exciting for me, at least, as we're playing around with this model, Petar, we're thinking about how do we incorporate this as part of our systems. And one of the big projects that we're working on, and it's kind of come full circle, JC, because if you remember 10 years ago, we talked about our next, right? We called it next, this idea that you have a system that has all the context and it's reasoning about what type of messages or what type of actions can you take to move a student along a particular journey based on where they are. So you can move them along a prospect journey, you can move them along an academic journey by giving them pieces of information, by giving them nudges. The book Nudge was a big factor at that time as well.
Which it still holds, right? A journey as a consumer journey is about the constant nudge and flow. Think about TikTok. One of the best models for attention grabs is about the constant nudge of going in the infinite scroll loop, right? So that's basically what we're trying to deploy. What does it take in a student journey to basically be nudged? So you always engage and giving the attention to the brand, the university, and whatnot.
Exactly. So we're coming down full circle as these models are actually able to not only reason about or not only output, a bunch of content and help us build these simple agent systems, but now we can reason for much more larger context. And I don't want to leave by not highlighting how can this impact our work that we're doing better as we release this proactive assistance and over the next couple of months.
Right. So imagine, again, the current limitations are this thing is not fast, so you cannot run it kind of like on the front-facing side.
Right, but it's in the background, right? It doesn't care.
Running in the background, and it's like a strategist, right? It goes in, and if you give it all the context, for example, if you're looking for a student that's a prospect and you might want to kind of like lead them to be an applicant potentially and even enroll, you need to analyze a lot of data points, right? You need to look at all the conversations the student has had with staff and kind of where they, said something specific about their needs. You want to look at every time they submitted an RFI form, like what do they actually select there? What's their interest? You want to look at their behavior, right? Are they interacting? What pieces of content are they interacting? Are they entering certain websites? How much time they're spending? Where they're going next? Are they interacting with our emails? With which emails are they interacting? And also staff side, right? They might already maybe reviewing the applicant or the prospect and putting some notes and, hey, this might be a really good fit for us because of X, Y, and Z. So there's all this data scattered. What if you connect all that and give it to this reasoning engine to produce next steps with a certain goal? And your goal is, hey, I want to convert this prospect to an applicant. And here's all the things we have that we had in this relationship with them. How can this help? So why this might be faster than a human? Of course, because you can run it in an infinite scale, right? Second is it's just hard for a human to connect all the dots,
Yeah.
right? There's so many things all around that you might interleave or not look, or maybe make it that's not that important. But the AI model will not look like that. It will take everything like at the same kind of quality. So I think that's a really really good use case. But you can apply this for anything else that needs to like take a lot of data points, analyze, and then predict the next step. So
And
that
if I may, the scalability of this, it's the really exciting thing. Why? Because traditional human thinking today is, I need to nudge you. You're an applicant, so I want to make you a deposit
Right.
person, right? That's a gigantic leap. It takes 55 events, 25 emails, like whatever. So basically, the micro steps of nudging next, it's basically a smaller permutation of flow and engagement. It's continuous, and the scalability is really exciting. Why? Because it's small, and computers are much better at doing that. And Ardis is the email guy. Petar is the video person. I am basically all the above, but only in the morning. So it's now time, and just basically doing it for thousands of variations. It's where this is now available. And as humans, we cannot do it. For the life of me, I cannot keep up with the permutations of my kids, two of them, right? So just think about doing this for thousands of users with all these different expectations of what do I need to move to flow in my next move.
Yeah. We've tried this before, right? We've tried it with recommendation engines, and we've tried
Yeah.
it with things like, hey, here's a whole lot of data that we have, like activity data, and then let's try to predict something next, or what the next activity should be. But it's still missing, right? There's still, like, you have the cold start problem, which is,
Yeah.
if you don't have that data for a specific novel use case, or for a new institution, or for a new campaign, the prior data doesn't really match it. But as humans, we can come in and we can say, oh, you know what, like, I can make this connection and this connection based on the context that I have, and I can probably figure out the best next use case here based on psychology, based on other fields that might not necessarily be available in my prior training data. Like,
Right.
I didn't load in and said, oh, I'm going to grab the psychological profiles of these people, or I'm going to base this model on psychological like, that's not available. But the reasoning models, these large language models that are reasoning, they can reason about, because they have all the knowledge, and they can go in different
Correct.
directions. Say, oh, I understand that they log in at night and they're from this location, and there might be additional context that comes with that nuance, right? The nuance part. So it's very, very exciting, and kind of yeah. Go ahead,
and
Petar. I kind of stole your thunder a little bit there.
compared to the previous systems, right? As you said, you can recommend the next action, but can you do that action at a segment of one? If you have 10,000 people that you're now taking into
Right.
consideration, you cannot.
Right.
That was never possible before, but this
Right.
technology now makes it possible. So that's the difference. Whoever can solve this at scale, that's it. That's the next iteration.
And
Yeah, exactly.
Element has done it, everybody. It's done. Just come
Good
and,
go.
and buy the product. It's done. It's done.
No, we're here to talk about O1 model by OpenAI, but it opens up so many different possibilities for everybody. And
Yeah.
what this is going to allow us to do not just us as marketers, because essentially at the bottom of this, we're marketers, right? We're trying to move people along around a particular journey, and that's what marketing does. It's like you have a goal and you're trying to move them along and provide content around them. But what this allows the ability to do for an organization, as a CEO now, I'm thinking in my head, I'm like, okay, I have someone new who comes to the organization. They don't have the context. They might not even know, how these things are affected from marketing, how sales is affected, how customers are affected. So if I provide this some reasoning, can it provide a chain of thought? Can it provide an output that a human can read it and say, oh, I understand why you actually came out to this conclusion, like without the boss or without that senior person telling them that, oh, you have to do this and this and this, and then by the way, if you mess up and you fail at this thing, that's where the learning comes in. Well, now they can look at the reasoning and they can look at that process and say, oh, this is how you get to that output. And it just reminds me a lot of, because my kids are in they're in that stage right now where they have to show their work on how they get their math problems done and their reasoning problems in geography and like trigonometry and all of that stuff. So they have to show all their work, right? And it's kind of makes total sense. It's like showing somebody the work on how you get there is, I would say,
Those are the principles, like
the
the work
principles,
shows the
yeah.
principles,
Look,
and then you
it's
can
it's
solve a variety
it's
of problems.
what we're seeing here, and maybe in recap modes, leading towards
Recap
this
mode.
episode, right?
Bring
Everybody,
us home.
yeah, XAI, the idea of explainability in AI is part of reasoning. We're seeing it today, and what Ardis and Petar kind of gave us is that this model now has this sequence of steps, and we can see it. We can see how it got from input to an output, and then here's the output. There's a tremendous opportunity for these hybrid human AI collaborative things, and I think it's getting there. And obviously the performance, the compute power, the moving the benchmarks forward is basically what is being deployed. I really believe that this type of deployment is expected. So I'll leave you with, I guess, if all of us can do a round of how does this feel? When I see this, I'm not surprised. I'm not wow. The technology, it's impressive, of course, and I applaud because I know how much work it takes. But at the stage where the technology curve and adoption, this type of innovation, incremental, is needed, and I'm so happy that it's happening now. Right, so amazing, and in a way expected. What about you two? How you feel now that you've seen these and had this conversation?
Yesterday I talked to Ardis as soon as they published. So he kind of called me, and then and he's like, "What are you doing?" I'm like, "Yeah, I'm watching everything and like seeing what's going on," and like not thinking of the like how you apply it for your business. I was like more on like, hey, how it changes the world, right, for day-to-day usage, right? So you don't have an expert math tutor, right? You have they can help you like solve or learn some new topic, right? And that's something that, for example, I struggled in my high school or my actually primary school. I didn't have good like math teachers, so like just getting that tutoring, for example, or just going deeper on a really complex topic, right? That being something in economics that you want to understand, or how explain me tax system, right? Explain me why it operates, why is it useful. Like some of these things are nuanced, and you want an expert to explain it to you. And before it was really hard. You need to search and figure out. You need like months to actually get there. Now you can code a whole game in one shot. Like you just ask, hey, can you code me like a snake game, and it creates a snake game. And like, well, I want the snake game to be called by my name and to put obstacles with my name around it, and it does that. And I can just copy paste put it. I mean, they were doing that before, but they had always issues. So if you're not an engineer, you need to like to prompt it back, eventually to make the code work. Now it does that for one shot, at least for simple, somewhat simple games. Imagine this: you have your kid is bored. You're like, hey, I want to create a game just for them, and it's like branded for them, and like, hey, go play, right? Or like, hey, I want to create a really really unique story for my kid, and then so it's how that impacts you day to day if you use this as a tool, like makes so much things easier, like your life, So that's what I'm really impressed and motivated to see how this will go and yeah.
Yeah, for me, it's a number of different things, but essentially, I think Andre Karpathy he did a recent podcast. Petar, do you remember what was the channel?
One sec.
So we'll anyway. So if you go to YouTube and say recent Andrej Karpathy interview, but he's the what is
No
it?
priors. No
No
priors.
priors. On the No Priors podcast, there's a video, and one of the
Ovation.
questions. Yeah, one of the questions and the thought process there is that he's very bullish. And for those of you who don't know Andrej Karpathy, he's an amazing engineer, and he's one of the folks behind the Tesla self-driving cars. He was at OpenAI for a really long
I
time.
thought you were gonna say he's a chess master, a chess player. He has totally the name of a chess master player. Just saying. Just saying.
Eastern European, of course. So, but essentially, what he's saying is that this transformer models, they're really, really good at absorbing information, and it's almost a miracle that the scientific discovery. This is a scientific discovery in computer science in how these models can absorb, and how these transformer-based models can absorb information and almost
Right.
have infinite recall and instantaneous recall on any piece of information. And one of the things that he mentioned is that they are really good at understanding and recalling information based on what is given. But because the training data has been mostly the output data, right? So we give them the output data, which is all of the internet, all of the information on the internet is only output. None of it's got very, very little input, meaning like what went into all the 500 drafts of a book and all the comments from an editor to make that book better, starting from a draft to getting to a final book, or a blog post, starting from an idea to get to a final one. So we only have the output versions of this content, of this human knowledge. We don't have the steps in between. So those models are not able to understand how do you get from an idea or from this concept, and how do you figure out all the pieces and all the things that you need in between to get to that final output. The benefit and the area of research right now is in producing data that is showing all the intermediary steps so we can get to an output. And then these models, they can configure and recombine those different steps in order to get in, when they introduced with a new novel idea or with a new question, they have the blueprint, and they have the instant recall on how do I get from this place to this place. I'm going to use all these different steps, recombine them, do all these different things. So the reasoning part is what gets me really excited, because this is kind of the next wave. Until now, these models can reproduce anything that is available in the internet. They can reproduce the output that we have available to us, from books to blog posts to social media posts to anything. For example, like strategic plans, all of these things as the output, but they never have been able to do the steps in between and reason about how to get there. So now we're able to solve real problems without having the ability, without introducing a person in the loop, so to speak. We don't need a person to guide the model to say, no, this is wrong, go in this direction. No, this is wrong, go in that direction. These opens up the autonomous agents that we're talking about, these agentic systems that we can now build in the background and have them be very, very good, because we can trust it that it's going to do this thinking and this process going back and forth to get to that output without having a human evaluate it, so to speak. So that's what's really exciting for me, and opens up kind of this huge frontier of automation and AI solving real problems.
Human in
Sorry
the loop,
for going.
Ardis. Human in the loop.
Please don't, please.
This removes the human from the loop, right?
That's the whole episode. I love what you're saying, but I leave you everybody with this thought: are we there? Human in the loop. It's we're gonna come back to another episode. We're gonna have the episode on the problems that we want to solve and compare them, and the other one is where are we at in human in the loop. And my position is that why do we want to remove the human in the loop? Because it's the human way in which how we solve problems. The example I just gave you is how would you do this, right? The CMO, and then
We're
you need
going
to ask
into the
3 or 4
next
questions.
episode right now.
That's my
JC.
point. That's my point. You're supposed to wrap it up.
I
and
wrapped
like
it up. I
open-
wrapped it up.
You opened up 3 kind of worms that are awesome. I just want to go there, but I think we're out of time. I think
All
we're out
right,
of time,
everybody.
right?
Until next time, Petar, good having you on the show.
Always.
JC,
Petar, you're the
always
best.
a pleasure.